Starting the started to record. So let's discuss about few mathematical functions first, which is list out all the functions. ABS, it's called absolute value, and ceiling, which is used to find the seal value, and floor, and we have power, and we have square, and we have square root, and we have rand, okay. So these are a few mathematical functions that are available in the SQL Server. So let's discuss one on one. So what is this ABS, absolute value, means? So whenever we get a negative valued number, let's say so -10, absolute value of this -10 will be considered as just the 10. So this is the concept of absolute values. So whatever the negative values that we get in, that will be converted to positive equivalent values. So let's see how it works. Usually we use select statement for any of the functions to get it. Let's see, let me use the same example that I've considered. Execute. So it says only +10. You better guys make a note of these functions, because these are the functions that are very much useful in real life scenarios. First one is ABS, which acronymed for absolute value. What it does is it does just make a negative number a positive number. And the next one is ceiling, CIE. The next one is ceiling. Oh, thanks, Shaman. In the previous sessions, what and all topics we discussed are kind of very basic, except the yesterday session. So you better be practicing it well just before getting into real fields. So then we discuss about ceiling. Ceiling, in the sense, like in a regular meaning, in a real, like normal life, ceiling actually means floor, or like top of the room. So that's what this ceiling keyword actually does. So it just gets suppose, let's say I have a number called 10.5 or 10.6 or 10.2, whatever. Ceiling of these particular two numbers will be rounded off to next individual number, next normal number, that is of 11. This is what the ceiling function does. So when we try to get a ceiling value of a particular fraction number, let's say 10.6 for an example, as we discussed, let's see, it returned 11. And let's see what if it's this 6 to be like 2. It's near to 10 value, but what it returns, this also returns 11. So this is the value, this is the functionality of ceiling. Absolute value is to give absolute number, ceiling is to give what you call nearest upper boundary,
round figure.
upper round figure. Yeah, that's better one. And floor, this gives nearest lower round figure value. So absolute, which gives 10 as output. This ceiling gives 11 as output. And we have floor function. What it does, it actually gives a lower round figure of the value. Not the round figure is round figure is not the proper way to say it. It just gives the proper decimal value with pointing to point naught. So let's say let's consider the same example, 10.6. What it gives is 10. Whatever the decimal like fraction value after the normal digit, it will be like rounded to nearest zero. And let's go for 10.2. Pardon me. This also gives the value 10. So whatever the value comes in, it just gives a lower bound. And how about the negative values? Negative values for flow. Select floor of minus 10.2. What it gives? Anyone has an idea? Minus 11. What it actually did? Let me explain. So whatever the value that we pass in, it just goes to the nearest lower boundary. So minus 10, minus 10 point something, whatever the value is, its nearest lower boundary is minus 11. If it goes to 10, that will be the upper boundary for it. So same one, if we go for ceiling function, it actually returns minus 10. Let's see. Ceiling of minus 10.2, it should return minus 10 as it is. So this is about ceiling and floor functions. And we have power function. See, in few mathematical functions, like in few mathematical calculations, we might be seeing like 2 power 2 or 2 power 3. And in the first class, as I said, the ranges for each and every data type that are given in terms of power. Let's say 2 power 31 to 2 power 31, minus 2 power 31 to plus 2 power 31. That's the value of 4-byte memory allocated data type. So same way, if we want to calculate that particular power values, this function is very much useful, and this is the only function we use. So select power, and it takes two parameters by which like we can see power function take, it requires two arguments. Whenever you are not sure of any other function, just place the cursor on it. It takes built-in function for expression returns blah blah blah. So I want to raise 2 to the power of 3. What will be the output? It's 8. What this means is 2 power 3. That is 2 cube, which is equivalent to 2 into 2 into 2. This is what the power actually means. So whatever the number that we pass in as a first argument will be multiplied by itself with second number of times. Let's say I want to calculate 5 power like 5. Select power of 5 comma 5. It should return a value which is like the result of 5 multiplied by 5 times. 3125. Let's just verify that. 5 times 5 times 5 times 5 times 5. 5 5 is 25, 25 5 is 125, 125 into 5 again. It goes like 725, I guess. 725 into 5. This is what the result, 3125. So this is how the power works. And for another example, let's take this 5 power 4. What it should be written? It should be written, I guess, 725. Sorry, 625.
625.
Yeah, my mistake, guys. Pardon me. So this is how the power works. If we are good with power, I'll move on to the next one. Next one is square. Square is nothing but whatever value we pass on, it will be multiplied by itself. So let's say if I want to find like 2 square, I'm just writing it for a purpose, but in like normal life, we do this 2 square or like some 9 square. This is how we write in real life, in real mathematics conditions. So let's say, let's calculate square of 9, what it should return. So 9 multiplied by 9, which is of 81, that is what it returns. So I want some other calculation, like let's go with bigger ones. I want 125 square. 125 multiplied by 125, it's 15,625. So this is how these mathematical functions are very much useful to go for the faster calculations and like to be handy. And we have square root function. Square root is nothing but let me put it in this way. Square root, we define it as sqrt. This function, what it does, we have seen a square value, square, the number multiplied by itself gives the value. So if I go with square root of 15625, 15,625, 15,625, let's select what it gives. It gives 125, such that it is exactly opposite way of square function, square and square root. Like we divide this number with some number which is like almost equal. Let's see, select sqrt of 81, which gives 9, which actually means 9 times 9 is equals to 81. What if I have this particular number? It gives this particular number 8.94444 and dot dot dot. So if you multiply this particular number by itself, it actually gives 80 as the value. And what else we have? Okay, rand. Rand is the one function that actually gives the value whatever we pass it on. Select rand of 1, it gives what it gave, some random number under 1. Let's say rand of 1000. Now, and we have one more thing, rand multiplied by 1000, which actually should give any random number within 0 to 1000. Let's see, this is how it is, 713. So if I apply floor function on the rand, what it gives, a perfectly random number from this particular value. I guess it's not the random value, but just the number. Always returns the same number. Rand is the one which always returns the same value. So this is about rand, and what else do we have? We have like string functions left, and some other useful functions that we will be using in real time. That I'll be continuing in the next session, which is tomorrow's session. For now, these are the mathematical functions that I have given you, and now I want to talk about joins. And guys, we have discussed about aggregate functions in the previous sessions. Uh, I'll mention them now, which is of average, count, sum, minimum, maximum, and we have like these are a few of aggregate functions. And whatever discussed we did today, those are mathematical functions. So these are like functions categorized into different types, and we have string functions left, inside the what called functions main division, string functions and date functions, and we have another like miscellaneous that we will be discussing in next session. And today's agenda is about mathematical functions and about joins. Let's go with the new tab and let's go with joins. We have set of joins actually. Let's say we have a few inner joins and like outer joins. Joins are of like I'll mention the points like inner join is the one, inner unjoin are the different keywords, and we have left join, and we have right join, and we have full join, and we have self join. What is inner join? So what actually join is? So join is the concept where we use to connect two or more tables together, or to link two or more tables. So this is about joins. So what does this inner join do? Inner join is the one. Let's say I have table 1 and table 2. These are two different tables which has different which has like two different data. Let's say table 1 has some uh, IDs and with customer IDs with customer name and order IDs available, and table 2 is all about orders. Let's take that example, and inner join is the thing, is the join by which we get only common records, like whatever the matched records are available. Let me try to share another screen for you with you guys. Yep, this would be a better one. So let's say this is the table 1, and there's a table 2. For example, table 1 and table 2. Inner join is the thing which gives only the values or of this portion. So this is the table 1, and this is tab 2. This particular thing will give, just a minute if I can, um, I guess I don't have the fill option. Okay, that's not a problem. So if I do inner join between this table 1 and this table 2, this table 1 and table 2, what it actually does is that it just gives all this area only, like whatever the common records between table 1 and table 2, that are of these things, matched records. So this particular section, we call it like matched records, that will be returned with inner join. And we have another one, left join, which is almost all same. Left join is the one by which we get all the details from the left table and matched records from the right table. So by which I mean that all the records from table 1 and matched records from the table 2. If I have fill option, that would be better one. I guess I don't have it. If I don't have the fill option, let's say this is the table 1 and table 2 data. This is the common data between table 1 and table 2. If I left join these particular two tables, I will get all the details from the table 1 and matched records from the table 2. So all this particular section of this particular table will be available. And if I go with the right join, whatever the details available in the right table, all the details available in the right table, and as well as the matched records from the left table. So that means this particular section will be returned from the table 2, sorry, left table. What about the full join? Full join is about all the section of details. So all the details of table 1 and table 2 will be returned right away. And how about self join? Self join is the one, uh, let's say we have table 1 and it joins with itself. So that is about self join. We'll discuss them in detail. So any doubts still here, guys? I know joins are a little bit clumsy. ANSI format or non-ANSI? What is it about, Jack? Is all about ANSI, the new ones, which are like categorized into inner and outer joins. We call inner join as inner and outer like full outer, left outer, right outer, and we use on keyword. So it's actually completely new one, and we have cross join and natural join also that we'll be discussing in the end. Those are like subsidiaries for this. Uh, are we clear, Jay Kishore? Well, let's see if we have any data that is available. I want to find human resources dot employee and department. Let's take that tables. See, this particular database, AdventureWorks 2012, is the one which we can import, uh, like take restore or restore from the backup files which are available in the internet. This is best used for practices. I've just downloaded it and restored it so that it's available, like all the details are available right away. Let's see. And I'm going to do employee and department tables. I'm going to take human resources dot employee and human resources dot department tables to demonstrate these joins. Okay, I clear? For that, we need to use AdventureWorks database. For that, we can use a direct keyword called use and followed by a database name, or just go to this drop down and select our AdventureWorks database. Whichever it is fine to go with. So I executed the command and it says and done. And here my drop down changed to AdventureWorks 2012. So I want to see the data. Human resources dot employees. This is the one table. Another table, human resources dot department table that I want to use for these two. I want to use for demonstration of the above joins. So let's execute one by one. No issues on that. So we have business entity ID, national ID number, login ID, organization, blah blah blah. We have a lot of things. And current fab, I guess we don't have a department available. Business entity ID. Let's see. We have department related data here, well and clear. Let me check what is the link here. Let me see if any other table is available. We have employee department history, employee pay history. Yeah, it is available here. Okay, let's see these details. So I have the table called human resources dot employee history, which actually has the history of the employees department data. Small change in plan. Instead of using employees department, I'm gonna use employee and employee department history. So for this, I have business entity ID, which is of I guess the employee ID, and in the history of the departments, we have employee ID and the department ID he belonged to. Okay, I want to see which employee belong to which department. So for that, I should be using department and as well as department history, because I have the employee ID available in here and the department ID available in here with the employment history, but I don't have department name available in the employee department history. For that, what we'll be doing, that is about the inner join. So select it's about business entity ID, comma department ID, and the name of the department which he is available in. So I'll be having that in this particular department table. So I'm gonna take name from this table, from what are the tables I want to join on. I want to join these two tables, employee department history, and as well as the department, to get the department details of each and every employee. So what I'm going to do, I just take employee. So I want to get employee ID and department ID, and as well as department name. So this gives me like the employee name, employee who's belongs to like which department. So for that, I want to join the two tables, which is a inner join. So if I take the inner join, I'll get only the details of a common records. So I don't get any details of the employees who are not belong to any other department. So for this, let's take the table and keyword inner join, and the table, the second table, human resource department. On what is the condition that you want to match the records on. So I have department ID common in both the tables. So department ID is equals to department ID. Here we have one problem. If you see this, we have business entity ID and department ID in one table, and the name in other table. Name is in different table. And we have department ID in both the tables, which is kind of like ambiguous data for this particular query. So what we will be using to overcome this, we have discussed the concept called aliases. So that we will be using here. So if you want to go get over, so we'll be using aliases here as employee department history, EDH, and we have department as DPT. Here, let's see, and we need to get the department ID from the department table. Now the red line's gone, and we have to see, check the condition or match the condition records, like check the condition from both the tables department ID. For that, I have employment department histories department ID, and as well as departments department ID. So this is how we use aliases for the table names as well. So instead of, and there is one more option to do this without using aliases. That is about instead of using this EDH, you just need to use human resources.employee department history, the full table name. Instead of using full table names only, we given that alias name. Let's see what is the output for this. Yep, we have a business identity. Okay, let's sort on business identity. Let's go with order by condition, order by business entity ID. This is how it works. So employee one, who is belong to department 16, he's of the department name called executive. So this is how we get all the we joined two tables on a condition called department ID as common one. Here I have joined two tables but got the details all of together. So this is about inner join. And what if we want the employee name also? So I don't have employee name available in either of these tables. What if I want the table, I mean that name also? So I want to get it from the employee table only. So this is where joining three tables comes into picture. In a join, human resource dot employee as EMP on the condition called EMP dot business entity ID is equals to, and we have employment department histories business ID. So EDH dot business entity ID. With this, we have one more problem with this query. So what is that? We have business identity ID in common with both the tables. So to overcome that, we should be giving the details of any one particular table. So let me take the EMP tables business entity ID. Let's see how it works. Let's go to end and execute. Yep, we have the same details as previous. That is because we did not give the name of the from the table employee. So we have a field called what do we have? We just have the login ID. How is it? We don't have the employee name in here. That is strange. Let's see if we have any other table that has the employee details. We have person. Maybe that should have. Let me try getting the details. Yes, we have. So instead of joining with the employee table, we just join with the table called person from the person data structure. Sorry, the main schema. So instead of joining with employee table, I'm gonna join with person table on the same condition. Let's see how it works. And here same result as because I did not give the name of the employee from the person table. So here the name is first name, middle name, and last name. We have three of them. So let's say this particular name has to be renamed to department name to give get out of this ambiguous results. So as the PT name, comma EMP dot what we have as name, first name plus EMP dot last name as name. We use quotes if we have multiple things to define. Let's execute this. This is what we have. So we have business entity ID, which is of employee ID, department ID, and we have department name and the name of the employee from different tables. This is how we join like multiple tables or like uh, dual table or multiple tables in this way. And we have left join in the next one. I'm going to use same tables, person and all these things. So now we use person table, person, and let's see what we have the details of the person. And we have only common ID, sorry, we have only business ID, business entity ID common for other data type, other tables data. So let's say person and the human resource dot employee table. I don't know like what is the data present in this particular tables, but let's see. Select star from, we don't want the stars. So let's see whether the employee belong to, whether the person is an employee of a particular company or not, or let's say about the department history. Obviously this doesn't make sense because every employee will be assigned to one or the other department, or let's try for that. Business entity ID, and what do you have from employment history or from the human resource, whatever it is. Okay, let's take employment history only. Yep, we have business ID and the department ID in common. ID and left join human resources dot employee. On the condition is person dot person. One second, person table, what we have dot business entity ID we have, which is equals to, and employee dot business entity ID, and we have business entity ID in common with both the tables. Human resources dot employee, we have, do we have it, the department ID? Let's see. Yeah, we don't have it. Then what is the table that we should be using? Human resources dot employee is this department history. So this is not the deployment, and this is person table. Let's execute this. We have plenty of employees that are like not defined, not mapped to any other department. So I have this entity, business entity ID in the persons table. Like there are hundreds of people available in my company, but few of them are mapped to department. So as I said, left tables data, all the data will come into picture, and right tables, which are matched ones, only will come into picture here. So this is how it works on the left join. So whatever the complete details about this person table, person dot business entity ID, and we have what is called a left joined with human resource dot employee department history. That is with, so the person will be the left table and the employee department history will be the right table. The match all the records from the employee table, sorry, the person table, and match records from the department history table, that will be coming up here. Did you get this, guys? Yeah, I understand these are quite new tables to process on. But if you guys are clear on it, we'll proceed to next one. Okay, Shweta. And anyone else? Okay, no problem. We'll repeat. Okay, you guys are clear with inner join, is it? Or that is also not clear? So inner join, is it okay for you guys? Yes, or somewhat clear. You should be very clear, Shweta. That's when we should be moving forward. So let me take another example. Let's say orders table, and we have customers table. Let's create a real quick. So these are the small tables that I will be creating to demonstrate this only. So let's create a table called orders, which takes order ID, OID, which is of int, and customer ID, who has ordered that particular order, that is also of int. And we don't want any customer name and all in the order table. And let's say ordered on, that makes sense. Ordered on, which is of date format. So I missed the keyword called table, create table orders, executed, and let's create the customers as well. So let's take customer ID as integer and name as care of some 10, I guess. Let's close it here. Let's execute. So we now have two tables called orders and customer. So let's insert some values into orders real quick. So order ID is 1. The customer ID who has ordered it is also 1. And ordered on is, let's keep it null for now. Am I clear till here? And let's go with order ID 2 and order ID 3 and order ID 4. And we have employee 3 ordered in here, and we have employee customer sorry, some 5 ordered this particular order. Let's execute all this, Okay, we have four rows inserted in, and we'll insert some other data into customers. Customer values, we should be having the customers 1, 2, 3. Customer 1, which is his name is A, and customer 2, his name is B, customer 3, whose name is C, and we have another 3 customers. Let's make it real change real quick. 4, 5, and 6, whose names are D, E, F. Let's insert this. Okay, what do we have now? The data. So we have customers called, oh man, a little mistake. Sorry, it's cursed ID. I've inserted all the values with the ID 4. Well, let's change that. So this is with ID 5 and this is with ID 6. Let's execute all these 3. Okay, now we have customers with IDs 1 to 6 and their names being A to F. And we have orders table, which order numbers are 1, 2, 3, 4, and the customers who ordered that particular like items or whatever. So I'll show the inner join first. Select orders. Orders, what we have, just the ID. Okay, OID, and what do we have? Cursed ID, and we have customer name. Cursed, what is the field name? Guys, be responsive for some time at least. From orders inner join on customer table. Sorry, inner join customers on condition. What is this? Cursed ID is equals to cursed ID. This cursed ID, what I'll be mentioning is that orders as I'm just giving the alias name here, and customers as C. Here I'm gonna check orders.customer ID to customers.customer ID. So are we clear with this particular statement? We are running out of time. Just real quick confirmations, please. Thank you. Let's execute this particular statement. See, whatever the orders that I have, 1, 2, 3, 4, that I'm mapping with customer table with inner join. So both the records only, the map only matched records will come. So let's say I have another value, another order value, which is of order 5 and customer name 7. I have one more row inserted. We have now, sorry, let's execute this. See, here we just have orders 1 to 4 only. But what about this particular order value? I just entered 5, 7. In fact, this is available in the database table, but it did not come. Why? This particular 7 customer ID is not available in this particular customer table, which failed the condition. So this is what the inner join does. Whatever the mapped or matched records from both the tables only will get displayed. Are we clear on the inner join here? Okay, so let's use the same example to get left join as well. So I want all the orders from the orders table and customer IDs who ordered that particular customer. Inner space, we just mentioned this thing. So what is the difference between inner and left join? In the inner join, we didn't have this particular column available. Did you get it? So whatever the left table's data, that will be displayed all in here. All the left table's data and matched right table's data, that will be pulled out. So whatever the unmatched records, that will be like placed as null. Okay, are we clear now? Left join. Yep, thanks Shweta, thanks Jay Kishore. And same way we'll use right join. Yep, thanks Anil. So right join is the one, it takes all the right values but only matched left table values. So let's see this table only, same way. It is just like we'll change this left to right. So here right table is customer and left table is orders. So I want to get all the details from the customer and match the records from the left table, which is of orders. Let's see how it goes. See, we have customer ID 11. This one is repeated just because we have another like multiple orders placed from that customer ID. So this is why it comes as duplicate in here only for the first records. And we have order employee customer 2 who did not order anything. That's why this order ID is null. So here, if you could notice, the right table's data, complete data is available in here, but only match records are available in this left table. So this is about right join. Are we clear, guys? I guess a small table data only like making you understand better, but in real time the data will be very vast. And we have one more join called full join that we'll discuss with the same example. Instead of this left, what is the condition that we use? Like we use full outer. What it actually does, it returns all the details from left and right tables irrespective of the condition, but the condition matched records will be on like on matched records. So this is what the data. So we have orders 1 2 3 4 5. On fifth order we don't have any customer details in the customer table, that's why it is null. And we have customer IDs 1 to 6, and these are the 3 customers who did not place any order, that's why these are null. Okay, are we clear on the full outer join? Yep. Well, thank you guys. And we have, what are we left with today in the joins? Only thing is self join. Yep, Jai Kishore, only self join. So for the self join, what do we need actually? So self join is the one which joins itself. It is like if I take an example, I should have done this customers table with little vast data. That would be a better option, or less like we should be adding the new columns here. So I'll tell you one thing. I want the customers who are from the same city. Let's add the column called customers right real quick. Alter table customers, add city of n, add care of some 10. Commands completed successfully. Let's see. We have city. I guess give me some cities names real quick. Have 6 customers, and I want at least oh, thanks, Bangalore, Hyderabad. Yep, that's enough, I guess. Okay, these are the things I want to update. Where sets it is equal to, say, all the rows are got affected and what the data we have. Okay, so in this, two guys are from Bangalore. One is customer 1 and the another one is customer 4. So I want to get the details who belong to same city, like in the group way. So what I'll be doing for that? For that, I'll be using inner join. Sorry, self join. For that, we'll be using this. Say, let's select customer name and city as customer city from customer. Let's say cust says C1, customer 1, and customer C2. This is how we do actually do this what it called mapping with this particular sorry, self join columns. We want C1's data and as well as C2's data. Okay, we don't have city or what? Yes, we have from customer 1 and customer 2, where C1 dot customer ID is not equals to C2 dot customer ID, and we want the same city, guys. So city C1 dot city is equals to C2 dot city. Let's execute this and see. Yes, we have two guys, A and D, are from Bangalore. So this is how we get the employees are belonging to same city with a concept called self join. So I did nothing, just that I taken same customer table with two different alias names with C1 and C2. And I want to like find another employee who belong to same city. That is where this condition. So did you guys get this? Are we clear on the self join? Okay, no problem. Okay, not clear. So Jai Kishore, my requirement is that I want to find an employee who like employees who belong to same city, whatever the city names. See, I have only two employees who map to belong Bangalore. So if I have another one employee who is like belong to Hyderabad, so that time I will be having two Hyderabad records. So in that case, I would be getting two employees from Bangalore and two employees from Hyderabad. So here, my condition is that city should be same and it should be of different customers. So customer A and customer D. These are two different customers belong to same city. So that is what this query does. So we are checking that condition on the same table, customer one, customer. So this is it with the self join, and we have and we are 17 past 8. Today it's a bit long session. Is it clear now, guys? Well, thanks, Jack Kishore. So this is the last one, cross join. What it actually does is it just does multiplication with all the records. So all the orders one have all the details of all the customers, and all the orders of ID2 will have all the same details again here. So I have like six customers and five orders. So that totals of 6 5 30 records. So this is what about the cross join. We will not be using the cross join like very quite often, but it's better to know about it. So this is about the session today. If any doubt, just ping me in the WhatsApp or drop an email. So we'll be closing off the session today here. Technically, we are 10 minutes late. We have started a little late today.